guys, welcome back to the channel. Jag here. In today's class, we're going to continue with our math and content. And what we're going to cover today is basically the trig ratios. For those of you who are comfortable with this, it will be a really good review. Okay, and I wanted to just mention that if your class is for grade 10 math on the trig unit, I already have the videos out for both the sine law and the cosine law, so make sure you check it out. Alright, so with that, let's get started. First, we're going to start off with the tangent ratio. So remember, whenever you're doing tangent, I'm going to put tan theta. Okay, the ratio is going to be the opposite over the adjacent. Okay, whenever you use the trig ratios, make sure the triangle is a right angle triangle. Okay, so what we're going to do is try a couple of questions from the textbook. Again, you're going to use your calculator. Make sure it is in the degrees mode or you'll get the wrong answer. Alright, so this question says, find the length of the unknown side to the nearest tenth. Okay, and I'm going to just draw out the triangle here. Okay, so for this triangle, we're looking for side x. Okay, it's a right angle triangle, so one side is given 4.2 centimeters. Okay, x, and this is 58 degrees right here. Okay, and again, remember when you are labeling the triangle, that's the first thing you should be doing. The side that is opposite is actually opposite to the angle that you're looking at. Okay, so here I have 58 degrees. I'm going to make an arrow. And you see where the x is? This is actually the opposite side. Okay, the one that's right beside the angle, this is the adjacent side. And the word adjacent actually means kind of like right next to. So this is the side that is right next to the angle. The longest side of the triangle is always the hypotenuse. It's basically the slant, okay, of the triangle, just in case you forget, okay? Another way to remember the hypotenuse side is that it's always opposite to wherever the right angle is, okay? So in this case, you see the right angle right here. Right across from there, that is always the hypotenuse. All right, okay, so I'm going to take off some of these arrows. Okay, now you're going to basically see which of these ratios am I actually utilizing. Okay, in this case, this whole section is actually just about the tangent ratio. Okay, but I did want to just show it to you. So say I'm writing the ratio for this now. You're going to take tan of the degrees, okay, for the angle that is given. So tan of 58 degrees equals to the opposite, and the opposite side is x, okay, over the adjacent side, which is 4.2. Okay, so just like this. All right, and I'm going to be solving for x here, and you can see I'm just going to move the 4.2 to the opposite side. So x is going to be tan 58 degrees times 4.2 on your calculator. Okay, and just put it in your calculator here. Again, it should be in the degrees mode, so tan 58 and times 4.2, so we are getting 6.7 centimeters. Okay, does everyone see how to do that? So you can see it's actually very simple, okay, using the trig ratios. The sine and the cosine will just have a different ratio, okay, compared to the tangent. Alright, so let's try one more example here. Okay, so I'm trying to see if we have, okay, these questions look the same, so let's skip down, okay, to number 7 in the textbook here. It says find the length of x, again, to the nearest tenth of a meter, okay? And, alright, so I'm just seeing if there is a question, okay, where we could do the degrees. So let's try this one. Okay, just want to show you a different type of question, not that they're all the same here. They look very similar to each other, okay? So let's try maybe this one. Okay, so this is my triangle here, and again, we're just going to look for the value of x. So this is 63 degrees, and across from there is 10 meters. So again, as soon as the teacher gives you the triangle, you have to make sure you are labeling it, okay, or you'll get the wrong answer. So right across from the degrees here, this is the opposite side. Right beside it, this is the adjacent side. Okay, so just like this. Alright, I'm going to write out the tangent ratio so I can solve for x. So again, I'm going to do tan of the degrees, so tan 63 degrees. Okay, and I have to make sure I do remember the actual ratios. Okay, so remember tangent is opposite over adjacent. The opposite side is 10 meters. over the adjacent side, which is x, okay? So I purposely actually chose this question just so we can see what you do if the actual variable is on the bottom here, okay? So one more time, we're gonna take, a good way to remember it actually is if the variable is on the bottom, I'm actually just switching the variable with the tan of the angle here, so tan 63. So this time when x, you're looking for x, it's gonna be 10 divided by tan 63 degrees. Does everyone see that? So a good rule to remember is if the variable is on the bottom, I have to make sure I divide, okay? I'm not multiplying here. So we're gonna do 10 divided by tan of 63 degrees. Make sure you're putting the equal sign here, and we're getting 5.1 meters, okay? And again, round all your answers to the nearest tenth, just as the question says. Okay, unless the teacher does indicate otherwise, then round to what the teacher is telling you to. Okay, are there any questions so far? Good. All right, so I want to go on, okay, to the sine and the cosine ratios. So first, maybe let's write out what the ratio is. Okay, so let me take this off. Okay, so this is just before we try an example of each of them. So if you're looking for the sine ratio, it's equal to the opposite, again, divided by the hypotenuse, okay? And you can see just the ratios are slightly different here, okay? If I'm looking for the cos ratio, so cos theta is equal to the adjacent, okay, over the hypotenuse. Okay, does everyone see that? So these are the ratios. I do have to memorize it, okay? And a good way to memorize this is what your teacher might tell you is the SOHCAHTOA. Okay, so let's write it at the top here. Okay, so it's like this. I always write down SOHCAHTOA, and you should do that. You write it on top of a quiz or a test before you start, and that way you don't need to actually memorize the ratios, okay? So if I look at SO here, this is sine, and the sine is the opposite divided by the hypotenuse. Does everyone see that? Okay. The second one is cos. It's adjacent divided by the hypotenuse. Okay, which are the ratios I'm writing down on the board. And the tangent ratio we went through is opposite divided by the adjacent. Okay, so one more time guys, SOHCAHTOA, and I don't need to memorize the ratios. I just need to memorize this slang, okay, or this saying here. Alright, so let's go to the textbook here. Let's try questions that are kind of similar, where you're looking for the side, okay, of one of the triangles. Okay, so again, when you do use the trig ratio, it does have to be a right angle triangle. Okay, so I'm going to take this off. Okay, and let's try an example, okay, from the textbook here. Alright, so let's try this triangle. So it looks like it's kind of like upside down here. Okay, I'm looking for the value of x. Okay, and the degrees here is 25 degrees, okay? As you're doing the questions, make sure you're also trying some of the questions that are like communication questions, because the teacher will put this on your test or your quiz, okay? Alright, so we're looking at the angle right across from this angle that's given. This is the opposite side, okay? And I noticed that the actual value that's given for 13 centimeters is the hypotenuse. And I know this again because this is the longest side. And the hypotenuse is always right across from the right angle, okay? So again, I'm looking at what's given to me. So I can see the adjacent side isn't given, and I don't need to use it here, okay? So I'm given the opposite side. I have the hypotenuse. So if you look here, let's take out these lines here, okay? I have the opposite, and I have the hypotenuse, or I have the hypotenuse side. I'm looking for the opposite side, okay? And because the adjacent side is not there, I just don't need to use the cos or the tangent ratio. I have to use the sine ratio, okay? Does everyone see how you're doing that? So I do have to decide on which trig ratio I want to use, okay? So we're going to do sine of the degrees. So sine 25 is equal to the opposite side. And the opposite side is x over the hypotenuse, which is 13, okay? So one more time, I can see that the variable is on the top here. And when the variable is on top, I just need to cross multiply, okay, the two numbers. So we're going to do sine 25 degrees times 13. Okay, and again, just put it on your calculator here. Okay, so 25 sine times 13. And we're going to round it to one decimal place here. It's going to be 5.5 centimeters. All right. Does everyone see that? All right, good. And again, you can see that the triangle can be like rotated. It can be kind of like backwards. Make sure you're just looking at the angle, okay? And make sure you are labeling all the sides, okay? So one more time, let's try one more example here, okay? I'm just seeing if we could do a different example. Okay, let's try this one. Okay, and again, all we're covering here is how to solve for the sides, okay, of the right triangle. So let's try this one. So say my triangle is like this, okay? I am looking for side x, and we can notice here right away, side x is the hypotenuse here, all right? And I'm given 50 degrees. Right across from the 50 degrees, this is the opposite side, okay? And across from the 90 degrees, this is the hypotenuse. Okay, so again, I have the opposite and the hypotenuse. I'm going to use the sine ratio. So sine of the degrees, so sine 50 degrees. Okay, and it equals to the opposite side. So the opposite is 12 centimeters over the hypotenuse, okay, which is x. So one more time, I noticed that the variable is on the bottom here, okay? And when the variable is on the bottom, I have to make sure I divide, okay? So I'm going to just make an arrow like this so you could see it. And the reason I make the arrows is so you know that the sine 50 degrees has to go underneath the 12 here, okay? It's not going to be sine 50 divided by 12. That's the wrong answer, okay? So if you're looking here, it's x equals 12 over sine 50. Okay, and this is going to be the value for x, okay? So let's put in our calculator, divide by sine 50, and we are getting 15.7, okay, centimeters. Okay, and this is my final answer. Again, maybe we should just box our final answers so we can see that. All right, so this is the answer for this right angle triangle. That's how you use the sine ratio. Make sure you are just watching whether or not you have to multiply or divide to get the final answer. All right? All right, so let's move on and let's do just an example with the cosine ratio. So I'm going to take this off. Okay, and we notice that it is actually very simple. Make sure you remember the SOHCAHTOA and don't memorize, okay, any of the ratios here. All right, so let's try this triangle here. So it looks something like this, okay? And I'm given 114 millimeters. This is x, and I'm given the degrees, okay? So again, one of the degrees for the triangle has to be given, or I won't be able to actually solve, okay? So here, right across, okay, from the angle is going to be the opposite side. Right beside the angle, this is the adjacent side. Okay, and this is the longest side of the triangle, which is the hypotenuse, all right? So again, I'm looking at the triangle here. I notice that I'm not using the opposite side at all, okay? So let's take this off so everyone can see. I'm not using the opposite side, okay? And in the sine and the tangent ratio, I do have to utilize the opposite side. So I can see right away, I'm using the adjacent and the hypotenuse. So this time we're going to utilize the cosine ratio here. So I'm going to put cos of the degrees. So cos 71 degrees. Okay, equals to the adjacent, which is x, over the hypotenuse, which is 114, okay? So again, I see the variable is on top here, so I'm going to multiply, okay, the two numbers. So we're going to do x equals cos of 71 degrees times 114, okay? So again, put it on your calculator. Depending on your calculator, you might have to put the number first, and then press the cos, okay, button on your calculator. And we're going to times it by 114. So we're getting 37.1 millimeters, okay? And again, make sure you are watching when you're doing the units and make sure your answer is correct, okay? So that's the final answer, okay, for this question. Okay, with that, let's try. Actually, let's try one more question here, okay? I'm going to draw it out. And again, I just want to make sure everyone is okay. you understand when you're multiplying and when you're dividing, okay, to get your answer for the sides. So let's try this one. Okay, so again, I have my right angle triangle. This is 15 degrees and x, and this is 8.4 meters, okay? So make sure you're labeling the triangle here. So right across from the 15 degrees is the opposite side, and beside the 15 degrees is the adjacent side, okay? Even if the angle is given and the angle is at the top of the triangle, the labeling will just change, okay? Again, the opposite side is always right across from the angle given, all right? And I see the longest side of the triangle here. This is the hypotenuse, okay, which is the x value. So again, I don't need to use the opposite side. I'm just going to take this off. Okay, I'm using the adjacent and the hypotenuse, okay? So we're using the cosine ratio. So cos of the angle, so cos 15 degrees, okay? It is equal to the adjacent side, and the adjacent side here is 8.4 over the hypotenuse, which is equal to x, okay? Does everyone see how to write the ratios? The teacher will be looking for this step, okay? So again, if you want to skip maybe the step right after this one, that should be okay. All right, I always just write down all the steps, okay, just in case. So I noticed the variables on the bottom. We're going to make our 2 arrows and just switch it around. So this time, we're going to divide. So x is equal to 8.4 divided by cos of 15 degrees. Okay, and then so put that in your calculator here, divided by cos 15. And we're rounding it to 1 decimal place, so 8.7 in meters. Okay, so everyone should just make sure you're double checking in terms of the units at the very end. I noticed that each question that we did here, the units were different, okay? And the teacher will take off a mark if you put down the wrong units here. All right? All right, so that looks good. And that brings this video to an end. So thank you for watching. Please make sure you like, share, and subscribe to the channel. And I will see everyone in the next video. Thanks. Bye.